Hey everyone, welcome back for another deep dive.
Thanks for having me.
Today we're talking about the Well-Architected Framework. And don't worry, we'll make it way more exciting than that well-architected framework.pdf sitting in your inbox.
Think of this deep dive as kind of like a cheat sheet for you,
Ooh, I love a good shortcut.
cutting through the jargon to give you the why behind building something amazing in the cloud, really.
So we've got this framework, which is basically like a builder's blueprint, right? It's all about making sure what we create is reliable, secure, crazy efficient.
And,
Good for the planet, right?
you got it. And the best part is these principles, they apply whether you're building like a global e-commerce platform or just kind of dipping your toes into the cloud.
Love that. Okay, so let's break down this blueprint. The framework is built on 5 pillars: reliability, security, performance efficiency, cost optimization, and sustainability. Plus, we've got operational excellence, which is like the conductor, making sure the whole orchestra plays in sync. Where should we start?
Let's hit reliability first. Imagine for a second that you're about to buy tickets for a sold-out concert. You're frantically refreshing the page, about to enter your credit card info, and bam, the site crashes.
The worst.
Frustrating, right? That's that's what we're trying to avoid with reliability. It's about making sure your workload, your website, your app, whatever it may be, just works consistently, no matter what.
Like that friend you can always count on no matter what crazy scheme you cook up.
Exactly.
So how do we make our systems that reliable?
And to make sure our systems are always there for us, we need to understand a few key practices. Think about it like this: building a house that could withstand anything, right?
Okay, I'm intrigued. What's the first step in building our reliable house?
First, you need solid change management. Think about those late night operating system updates on your phone. Annoying, maybe,
The worst.
but crucial for introducing new features and keeping things secure. Now imagine trying to make those changes to a massive cloud system all at once.
Chaos. Total digital meltdown.
Exactly. Controlled, planned updates are key. Next up, we've got failure tolerance, which is like having backup generators for your house. Let's say one server goes down.
The lights go out, panic sets in.
Not quite. With failure tolerance, we design for redundancy. Another server seamlessly takes over, and your users never even notice a blip.
Okay, I'm liking where this is going. What about natural disasters, though? That's got to be a concern, right?
Absolutely. And that's where disaster recovery comes in. It's all about having a plan to get back up and running after a major disruption, right?
Gotcha.
Think about it. Think about it like having your most important documents stored safely off-site.
So if a hurricane hits our metaphorical data center, we're not scrambling to piece things back together.
Exactly. Disaster recovery is about minimizing downtime and data loss, no matter what gets thrown our way.
All right, so we've got a rock-solid foundation for reliability. But what about keeping those pesky intruders out? Time to talk security, right?
Absolutely. Let's fortify our house.
Security. Okay, now this is where things get really interesting. Because it's not just about building strong walls, it's about being smart about who has the keys to the castle, right?
You're spot on. In the world of cloud security, it's all about layers. Kind of like those heist movies with the laser grids, pressure plates, the works.
And here I thought I just needed a strong password. So what's our first line of defense?
Think of security foundations as the bedrock. We've got things like preventative controls, which are basically the locks, alarms, and security cameras of our digital home. We're talking, service control policies, making sure only the right users can perform certain actions, configuration rules, keeping everything in check. But even with all that, we can't be too careful, right?
Right, like my grandma's got this super secure looking cookie jar, but somehow I always find a way in.
Exactly. That's why we have detection. Think of it like setting up tripwires and motion sensors. We're talking about systems that monitor for any fishy activity, like
Sure.
someone trying to break into your AWS account at 3:00 a.m.
Okay, so we're catching them red-handed, but then what? Do we have, like, a digital SWAT team on standby?
That's where incident response comes, in a plan for when, despite your best defenses, something slips through the cracks. Think of it as a fire drill. Who's calling the shots? What steps are taken? The faster and more efficiently you respond, the less damage is done.
Right, because in the cloud, time is money, literally. But let's rewind a bit to those intruders. How do we actually stop them from getting in the first place? Is it all about complex passwords, two-factor authentication, all that jazz?
Those are definitely part of the equation. Identity and access management is all about controlling who has access to what, right? Like Giving different keys for different areas of your house. We use things like strong passwords, multi-factor authentication, temporary credentials. So even if someone snags a key, they can't get very far.
So even if someone manages to swipe your grandma's spare key, they won't have access to the good stuff. Clever.
Exactly. And we're not just securing the perimeter. We're also talking about infrastructure protection, securing the very foundation of our cloud systems, right? It's like,
Ah.
having a moat around your castle, reinforced walls, the works.
Okay, I'm picturing some serious digital fortifications here.
You got it. We use network segmentation, which is like having separate fortified rooms within the castle. That way, even if one part is compromised, the intruder can't access the entire kingdom.
That's a relief, knowing we've got, like, layers upon layers of defense. But what about the crown jewels? The data itself. How do we make sure that's locked down tight?
That's where data protection comes into play. We're talking encryption. Your data is scrambled into an unreadable mess without the proper decryption key.
So even if someone got past all our defenses and snagged our data, it would just look like a bunch of gibberish.
Exactly. We also enforce, strict access controls, making sure only authorized users have permission to view or modify sensitive information.
And of course, backups. Gotta have those backups.
Absolutely, because even with the best security, accidents happen. Backups are like having a spare copy of your most valuable treasures stored safely in another dimension just in case.
Okay, so we've got Fort Knox levels of security for our data. But what about the software itself, the applications we're building? How do we make sure those aren't vulnerable?
That's application security, and it's all about baking security into the very DNA of our code. Think of it like this, even the strongest castle is vulnerable if it's built on a foundation of sand.
Right, a weak link can bring down the whole system.
Exactly. So we use secure coding practices to prevent common vulnerabilities, like SQL injection, cross-site scripting, all those nasty things. We also do vulnerability scanning, penetration testing to identify and fix weaknesses before they can be exploited.
So it's like having a team of ethical hackers trying to break into our system to find those weak spots before the bad guys do.
You got it. We're constantly testing, patching, and improving to stay one step ahead.
Wow. Security in the cloud really is a multi-layered beast. It's reassuring to know how much thought and strategy goes into keeping our systems and data safe. Speaking of strategy, let's talk about making sure all of this runs smoothly and efficiently. That's where performance efficiency comes in, right? Give me the need for speed breakdown.
You bet. Imagine you're browsing the web and a site takes ages to load. You'd probably just give up and go somewhere else, right?
100%. Ain't nobody got time for lag.
Exactly. In the cloud, performance is critical. Performance efficiency is about making sure your workloads are lightning fast and responsive, delivering that seamless user experience we all crave. And to achieve this, we need to be smart about our architecture.
Okay, so we're talking about the nuts and bolts of our cloud system, how it's all put together.
Exactly. Architecture selection is about choosing the right tools for the job. AWS offers a ton of services, each with its own strengths, right? It's like having a giant toolbox. You wouldn't use a hammer to tighten a screw. Right.
Okay, so we're talking about choosing the right tools for the job. But with so many options, how do we even know where to begin?
That's where understanding your workload comes in, right? What are you building? What are your performance goals? What kind of data are you dealing with? Once you have a clear picture, you can start exploring different AWS services, architectural patterns, that kind of thing. For example, let's say you're building a web application. A common approach is the web application hosting pattern.
Okay, so this is like a pre-designed blueprint for building a web app in the cloud.
Exactly. It lays out like a scalable and reliable architecture, so you don't have to reinvent the wheel.
Right, because who has time for that?
Exactly. You can find these patterns in the AWS documentation. They're a great starting point.
That's super helpful. So we've got our blueprint, we're choosing the right tools for the job, but what about the actual horsepower? How do we make sure we've got enough computing power to handle everything we're throwing at it?
That's where compute and hardware come in. We need to choose the right instance types for our workloads, making sure we have enough oomph.
Okay, back up a bit. Instance types. That sounds very technical. Help me out here.
Think of it like choosing the right engine size for your car. You wouldn't put a tiny 4-cylinder engine in a monster truck, would you?
Okay, that makes sense. Got to have the right horsepower.
Exactly. AWS offers a ton of different instance types, each with, varying levels of CPU, memory, networking capacity. Choosing the right ones ensures you're not paying for more power than you need while still meeting those performance goals.
So it's all about finding that sweet spot, that Goldilocks zone of performance and efficiency, right? But how do we actually know if our system is running at peak performance? Are there any warning signs?
Absolutely. It's not enough to just set it and forget it. Monitoring is crucial. Think of it like checking your car's dashboard. You're looking at fuel levels, engine temperature, all those vital signs.
Keeping an eye on things.
Exactly. In the cloud, we have tools like Amazon CloudWatch that give us real-time insights into our systems.
So we can see, like, if our CPU is maxed out, our disk space is running low, that sort of thing.
Exactly. CloudWatch is like having a team of engineers constantly monitoring your systems, alerting you to any potential issues before they become major headaches.
That's amazing. It's like having a crystal ball that shows you potential problems before they even happen. But what about the data itself? Data is the lifeblood of many applications. How do we make sure our data is stored and accessed as efficiently as possible?
That's a great question. And it falls under the data management aspect of performance efficiency. We've got to be strategic about where and how we store our data. AWS offers a range of storage services, each optimized for different needs.
So it's like choosing the right storage containers for your stuff, right? You wouldn't store your winter coats in your sock drawer.
Exactly. You need the right storage for the job. For example, for large amounts of data that you don't need to access very often, Amazon S3 Simple Storage Service, it's a great choice. It's like a massive, cost-effective attic in the cloud. But for data that needs to be accessed quickly, frequently, we have services like Amazon EBS, Elastic Block Storage, which is more like a high-speed hard drive attached directly to your server.
Gotcha. So many options. Okay, so we've got the storage part figured out, but what about speed? How do we make sure our applications can access the data they need as quickly as possible?
That's where data caching comes in. Think of it like keeping your most frequently used items within arm's reach. We can store copies of, frequently accessed data in a high-speed cache like Amazon Elasticache,
Oh.
so our applications don't have to go all the way back to the main storage every time they need it.
So it's like keeping your phone, wallet, and keys in your pockets instead of digging through your backpack every time you need them.
Exactly. It's all about reducing those precious milliseconds of latency. And then there's data compression. Squeezing as much data as possible into the smallest space possible.
Like packing your suitcase really efficiently for a trip, right?
Exactly. Data compression not only reduces storage costs, but also speeds up data transfer. And speaking of data transfer, let's talk about networking.
Okay, networking. This is where I usually start to zone out, but I have a feeling you're going to make it interesting.
I'll do my best. So imagine you're trying to access a website hosted on a server on the other side of the world. It's going to be slow, right?
Painfully slow, especially if you're like me and have zero patience for buffering.
Exactly. That's why we use content delivery networks, or CDNs. CDNs cache content like website files, videos, on servers located around the world. When a user requests that content, boom, it's served from the closest server, resulting in much faster loading times and, of course, a better user experience.
So it's like having multiple distribution centers for your content strategically located around the globe.
Exactly. Amazon CloudFront is a popular CDN service that integrates seamlessly with other AWS services. And then there's load balancing, distributing traffic across multiple servers to prevent any single server from becoming overwhelmed.
So it's like having a traffic cop directing cars to different lanes to keep things moving smoothly.
Perfect analogy. AWS offers several load balancing services, like Elastic Load Balancing or ELB. And we can't forget about choosing the right network connectivity options, making sure our data is traveling on the digital Autobahn.
Okay, this is where I usually get lost in the weeds. Are we talking about fiber optic cables versus copper wires?
Not quite that technical, but you're right, the type of connection matters. AWS offers a range of options, from AWS Direct Connect, which is like having a dedicated high-speed pipeline directly to AWS, to AWS VPN, which is more like a secure tunnel over the public internet.
So it's like choosing the right highway for your data to travel on a super fast toll road versus a scenic route with potential traffic jams.
Exactly. And just like with everything else, monitoring is key. We need to keep an eye on our network performance, identify any bottlenecks, potential issues, before they turn into major roadblocks.
Right, because even the fastest car won't get you very far in a traffic jam. So we've talked a lot about the technical side of performance efficiency, but what about the human element? Do our teams play a role in all of this?
Absolutely. We can have the most amazing technology in the world, but without the right processes and culture in place, it's not going to reach its full potential.
So it's not just about the what, it's about the how. how we work together as a team to make all this magic happen.
Exactly. The well-architected framework.pdf document emphasizes the importance of establishing clear performance goals, metrics, as well as a process for continuous improvement. It's about fostering a culture of experimentation and learning, where it's okay to try new things, measure the results, and learn from both our successes and our failures.
So it's about creating an environment where people feel empowered to innovate and optimize.
Exactly. And that includes communication and collaboration. We need to break down silos between teams, share knowledge, and work together to achieve those common performance goals.
It's like having a well-oiled machine where all the parts are working together smoothly and efficiently.
Exactly. By combining the right technology with the right processes and culture, we can unlock the true potential of performance efficiency in the cloud.
This is all making so much sense now. We've talked about building a solid foundation, fortifying our defenses, making sure our systems are running at peak performance, but, this all sounds expensive.
That's a common misconception.
Really, because I'm envisioning some pretty high-tech and probably pricey solutions here.
You're not wrong. Building in the cloud can get expensive if you're not careful. But that's where the next pillar comes in, cost optimization.
All right, let's talk about saving some money then. Hit me with those cost-cutting secrets.
Well, it's not just about cutting costs. It's about maximizing the value we get from our cloud investments.
Think of it like this, right? You can buy a cheap car that breaks down all the time.
Or you can invest in a reliable car that will last you for years.
Exactly.
Okay, I see where you're going with this. So it's about being strategic with our spending, making sure every dollar is working as hard as it can.
Exactly. And to do that, we need to kind of adopt a mindset of continuous improvement. We need to be constantly looking for ways to optimize our cloud spending without sacrificing performance, security, or reliability.
Right, because what good is a cheap car if it leaves you stranded on the side of the road?
Exactly. So how do we actually do this? Well, the well-architected framework.pdf document outlines 5 best practice areas for cost optimization.
5 areas. That's quite a roadmap. Let's start with the first one. Practice cloud financial management. Sounds kind of obvious, but I have a feeling there's more to it than just like balancing a tech book, right? You're right, it's much more than that. It's about having a disciplined approach to managing your cloud spending. This includes things like budgeting, setting limits on how much you're willing to spend on, different cloud services, forecasting, trying to predict future cloud costs based on historical data, usage patterns, and cost allocation, tracking cloud costs back to specific projects, teams, business units.
Okay, so we're not just throwing money at the cloud and hoping for the best. We're treating it like any other important business expense with careful planning and tracking. What's next on our cost-saving adventure?
Next up, we have expenditure and usage awareness. This is about knowing where your cloud spending is going and how your resources are being used.
Okay, so like itemizing your expenses, knowing where every penny is going.
Exactly. AWS provides tools like Cost Explorer that let you slice and dice your cloud spending data in a million different ways. You can see how much you're spending on EC2 instances versus S3 storage, track cost trends over time, identify any unusual spikes in your spending.
So we can catch those runaway cloud costs before they blow a hole in our budget. This is good stuff. What's the next best practice?
Cost-effective resources. This one's all about choosing the right resources for your workloads and configuring them in a way that, minimizes cost.
Sounds simple enough, but I bet there are some hidden depths to this one too.
You know it. First up, we've got right sizing.
Yes, right sizing, our old friend.
Exactly. We already talked about this in the context of performance, but it's just as important for cost optimization. Remember, we want to choose the most cost-effective resources that can still meet our performance needs.
Right, no need to pay for a Ferrari if a reliable Honda will get you where you need to go.
Exactly. And then we have the exciting world of AWS pricing models.
Okay, now this is where my eyes usually glaze over.
I promise it's not as complicated as it sounds. AWS offers several different pricing models, each with its own pros and cons.
So it's like choosing the right cell phone plan. Do you need unlimited data, or can you get away with like a pay-as-you-go option?
Perfect analogy. For example, we have on-demand instances, which are great for, short-term or unpredictable workloads. You pay for what you use, no long-term commitments.
Sounds flexible. What are the other options?
We also have reserved instances, which can save you a significant amount of money if you have predictable long-term workloads. With reserved instances, You're essentially committing to using a certain amount of compute capacity for a year or more in exchange for a discounted hourly rate.
So it's like prepaying for your gym membership to get a lower monthly rate.
Exactly.
Yeah.
And then we have spot instances, which are like, those last-minute travel deals you see online. Spot instances allow you to bid on spare compute capacity that AWS has available.
So you're basically getting a deal because you're using resources that would otherwise be sitting idle.
Precisely. If your bid is accepted, you can run your workloads at a significantly discounted rate.
That's awesome. So we've got our budgeting in order, we're tracking our expenses, we're choosing the right resources, pricing models. What's the fourth best practice for keeping those cloud costs in check?
It's called Manage Demand and Supply Resources.
Yeah.
And it's all about matching your resource usage to your actual demand.
Okay, so it's like turning off the lights when you leave a room. Don't waste energy on resources you're not actively using.
You got it. The cloud makes it incredibly easy to scale your resources up or down as needed. We call this elasticity.
Elasticity. I like it. It's like having a car that can magically transform from a compact to an SUV depending on how many passengers you have.
Love it. With elasticity, we can automatically provision additional resources when demand increases and release those resources when demand decreases. This ensures that we're only paying for what we're actually using.
Sounds like a recipe for some serious cost saving.
It definitely can be. And we can take this even further with techniques like buffering and throttling.
Okay, those sound familiar. Didn't we talk about those in the context of performance?
We did. And they play a role in cost optimization as well. Remember, buffering involves, queuing requests and processing them gradually, while throttling involves limiting the rate at which requests are processed. These techniques can help smooth out demand spikes and prevent your systems from becoming overloaded, which can lead to unnecessary costs.
So it's like having a bouncer at the door of your application, controlling the flow of requests to make sure things don't get too crazy inside.
Exactly. And finally, we have time-based scaling. This is about scheduling your resources to scale up or down at specific times of the day or week based on, predictable demand patterns.
So it's like setting your thermostat to automatically adjust the temperature at different times of day, even though it relates to scaling cloud resources.
Right.
Love it. What's the last best practice for cost optimization?
It's optimize over time. This one's all about continuously reviewing your cloud spending and identifying opportunities for, further cost reduction.
So like regularly checking your bank statements and looking for areas where you can cut back on unnecessary spending.
Exactly. It's about staying vigilant, being proactive.
I'm starting to sense a theme here. So we've got budgeting, tracking, choosing the right resources, managing demand, and optimizing over time. That's a pretty comprehensive approach to keeping those cloud costs in check. But what about the planet? Where does sustainability fit into all of this?
That's a fantastic question. And it's one that more and more organizations are asking themselves. It's no secret that the tech industry, particularly data centers, can have, a significant environmental impact.
Right, all those servers running 24/7 have to get their energy from somewhere.
Exactly.
Well,
But the cloud actually presents a unique opportunity to do things differently.
really? So the cloud can be a force for good when it comes to sustainability.
Absolutely. And that's where the fifth pillar of the well-architected framework comes in, sustainability.
All right, let's dive into it. What does sustainability actually mean in the context of the cloud?
It's about minimizing the environmental impact of our cloud systems. That includes things like reducing energy consumption, lowering carbon emissions, using water more efficiently, minimizing waste.
So it's about building a greener cloud.
Exactly.
Yeah.
And the best part is, many of the principles we've already discussed, like efficiency, optimization, right-sizing, they also contribute to a more sustainable cloud. But there's more to it than that.
Okay, I'm all ears. How do we actually go about building a more sustainable cloud?
Well, the well-architected-framework.pdf document outlines several best practices for sustainability. The first one is scale workload infrastructure dynamically. It sounds familiar.
It does. We talked about elasticity earlier, right?
Exactly. Scaling your resources up or down based on demand isn't just good for cost optimization, it's also good for the environment. When we only use the resources we need, we reduce our overall energy consumption.
So it's a win-win situation. Good for the planet and good for our wallets. What's next on our sustainability checklist?
Align SLAs with sustainability goals. SLAs, or service level agreements, define the level of service we expect from our cloud provider.
Right, things like uptime, performance, those sorts of things.
Exactly. Traditionally, SLAs have focused primarily on performance and availability, But what if we also factored in sustainability?
So instead of just asking, can we get 99.999% uptime?
Hmm.
We're also asking, can we achieve that uptime while minimizing our environmental impact?
Exactly. It's about finding that balance between performance and sustainability. And sometimes that might mean making some trade-offs. For example, maybe we don't need our systems to be running at 100% capacity all the time. Maybe we can afford to scale back a bit during off-peak hours to, conserve energy.
So it's about being mindful of our resource consumption and making conscious decisions to reduce our impact.
Exactly. And then we have stop the creation and maintenance of unused assets. This one's pretty straightforward.
Hmm.
If we're not using it, we should get rid of it.
Like that old treadmill in my basement that's gathering dust.
Exactly. Unused cloud resources consume energy, generate emissions, and contribute to e-waste.
So it's not just about decluttering our digital lives, it's about being responsible stewards of our resources.
Precisely. And AWS provides tools that can help us identify and decommission these, these unused resources.
Okay, so far so good. What's the next best practice for building a more sustainable cloud?
It's optimized geographic placement of workloads based on their networking requirements. This one's all about location, location, location.
Okay, I'm intrigued. How does location play into sustainability?
Well, data centers around the world are powered by different energy sources. Some are powered by renewable energy sources like solar and wind, while others are powered by, fossil fuels.
So by choosing to locate our cloud workloads in regions powered by renewable energy, we can significantly reduce our carbon footprint.
Exactly. It's like choosing to buy your electricity from a green energy provider.
That makes a lot of sense. But how do we know which regions are powered by renewable energy?
AWS provides transparency into its sustainability efforts, including the energy mix of different regions. They even have a carbon footprint tool that can help you estimate the emissions associated with different AWS regions, and they're constantly working to increase their use of renewable energy.
That's great to know. So we can make informed decisions about where to locate our workloads based on their environmental impact. What's the next sustainability best practice?
It's optimized team member resources for activities performed.
Okay, this one sounds a bit different. How does optimizing our teams contribute to sustainability?
It's all about reducing our overall environmental footprint, and that includes the impact of our workforce. For example, um, by offering remote work options, we can reduce the need for employees to commute to an office, which in turn reduces emissions from transportation.
So it's about empowering our teams to work in a way that's both productive and sustainable.
Exactly. And it's not just about remote work, right? It's
Yeah.
also about using collaboration tools effectively to reduce the need for travel, optimizing meeting schedules to save time and energy, and even encouraging sustainable practices in the office.
It's about creating a culture of sustainability, both inside and outside the workplace.
Exactly. And when it comes to the cloud itself, we can implement techniques like buffering and throttling, which we discussed earlier,
Mhm.
to to reduce the strain on our systems and minimize energy consumption.
Right, so those techniques have a double benefit. They improve performance and reduce our environmental impact.
Exactly. And we should always strive to minimize data movement across networks.
Okay, so the less data we're moving around, the less energy we're using.
Exactly. This means using data compression, caching, choosing storage locations that are close to our compute resources.
It's like planning your errands efficiently so you're not driving all over town. What's the final sustainability best practice?
It's backup data only when difficult to recreate. Now, backups are essential for disaster recovery, but we don't need to back up everything.
So it's about being strategic with our backups and only backing up the data that's absolutely essential, difficult to recreate.
Exactly. By reducing the amount of data we're backing up, we can reduce our storage costs and our environmental impact.
This has been incredibly eye-opening. I had no idea there were so many ways to make the cloud more sustainable. I'm starting to see that sustainability isn't just an afterthought, it's an integral part of building well-architected systems.
Absolutely. And it's something that AWS takes very seriously. They're committed to using 100% renewable energy for their global infrastructure, and they're constantly innovating to reduce their environmental impact.
That's really inspiring. It's great to know that we can build amazing things in the cloud while also being mindful of our impact on the planet.
Exactly. And it's something that more and more customers are demanding. Sustainability is no longer just a nice to have, it's a business imperative.
So we've covered a lot of ground here with these 5 pillars. We've talked about reliability, security, performance efficiency, cost optimization, and sustainability. But something tells me there's one more piece of the puzzle, one more ingredient in our recipe for building amazing things in the cloud.
You're absolutely right. We've covered the 5 pillars of the well-architected framework. Now it's time to talk about the how we actually put these principles into practice.
Okay, I'm ready for the grand finale. What's the secret sauce?
It's called operational excellence,
Right.
and it's all about building and operating systems that are reliable, secure, efficient, cost-effective, and sustainable day in and day out.
Sounds like the holy grail of cloud computing.
It is. And it's not something you achieve overnight. It's an ongoing journey of continuous improvement. But by embracing the principles of operational excellence, we can build systems that are not only technically sound, but also operationally efficient and resilient.
All right, I'm ready to embark on this journey. Take us to operational excellence.
Think about a world-class orchestra. You've got these incredibly talented musicians, each playing, a complex instrument. But without a conductor, without sheet music, without a shared understanding of the piece they're creating, it would just be noise, right?
Total chaos, a musical train wreck.
Exactly. Operational excellence is like being the conductor of our cloud orchestra. It's about making sure everyone is in sync, playing their part, working towards that common goal.
Okay, I'm starting to get the picture. But where do we even begin? What are the instruments in our cloud orchestra, so to speak?
The well-architected framework.pdf breaks operational excellence down into key areas, almost like sections of the orchestra. We've got preparation,
Right.
which is about having those musical scores, those run books and playbooks that guide our actions.
So if a server crashes in the middle of the night, we're not scrambling to find the right instrument, let alone play the right tune.
Exactly. Runbooks provide, step-by-step instructions for handling common operational tasks, like deploying new code or restarting a server. Playbooks, on the other hand, are our guides for dealing with unexpected events, like security incidents or major outages.
So runbooks are like the sheet music, and playbooks are like the conductor yelling out cues during a tricky passage.
Love it. That's a great way to think about it. And just like a conductor rehearses with their orchestra, we need to test our runbooks and playbooks regularly.
Right, because we don't want to discover that our sheet music is out of tune during the middle of a performance.
Exactly. And that brings us to another key aspect of operational excellence, continuous improvement. The cloud is constantly evolving, and so are our systems. What worked yesterday might not work today, and what works today might not work tomorrow.
So we can't just rest on our laurels. We need to be constantly learning, adapting, and improving.
Exactly. Continuous improvement is about creating a feedback loop, constantly evaluating our processes, identifying areas for improvement, implementing changes to make our systems even better. It's about creating a culture of learning and experimentation.
Okay, I'm really starting to see how operational excellence is like the glue that holds all the other pillars together.
Yeah.
It's about making sure we're not just building great systems, but that we're operating them effectively and efficiently over the long term.
Absolutely. And don't forget about communication. Just like the conductor communicates with the orchestra, we need clear and effective communication channels, within our teams and with external stakeholders.
Right, because even if everyone has the right sheet music, it won't sound very good if they're not all listening to each other.
Exactly. Effective communication is crucial for incident response, knowledge sharing, and overall team morale.
This has been an incredible journey. We've covered so much ground from the foundational principles of reliability, security, performance, and cost to the often overlooked importance of sustainability. And then we tied it all together with the magic of operational excellence.
And the best part is, this isn't just theoretical knowledge. These are principles and practices that you can apply to your own cloud journey, regardless of your technical background or the size of your organization.
Exactly. Whether you're just starting out with a small project or managing a massive cloud infrastructure, the well-architected framework provides a roadmap for success. It's about asking the right questions, considering all the angles, and making informed decisions that align with your business goals.
And remember, it's a journey, not a destination. The cloud is constantly evolving, so be prepared to adapt, learn, and continuously improve along the way.
Well said. A huge thanks to you for sharing your expertise with us today. It's been an absolute pleasure picking your brain.
My pleasure. Always happy to geek out about the well-architected framework.
And to all of you listening, thanks for joining us on this deep dive. We hope you've gained some valuable insights and inspiration for your own cloud adventures. Until next time, keep building awesome things.